Post.
Whenever you want. Okay, so good morning, good afternoon, and good evening, depending on your time zone. So welcome to this second webinar on this series of reproducibility initiative webinars. So the Supercomputing 22nd Reproducibility Initiative Committee is composed of multiple subcommittees and multiple chairs. I will not go into it, but I wanted to acknowledge all the members that are working on this initiative. And also I would like to remind you of the deadlines that we have for papers and for artifact descriptions and artifact evaluation. So abstracts are due by March 25th. And then the deadline for papers is April 1st. However, for the artifact description and artifact evaluation, you have a bit more of time. So you have until April 15th to submit your artifact description, which is mandatory. And then artifact evaluation, the actual software artifact, is optional, but is highly recommended. Okay. Okay, so you have the different submission forms and samples are available at the Supercomputing website. Okay, and check the different options that you need to specify. Okay, so Supercomputing has started this initiative towards the reproducibility on 2015, and with the objective of providing scientific rigor and pioneering the practice of reproducibility on accepted papers. Okay. So in the reproducibility initiative, you have like different subcommittees. One is the one that we will be talking today on the artifact description and artifact evaluation. This, as I said, is mandatory, the artifact description, and the artifact evaluation. Then you can apply for different batches. No? And a batch that is just an artifact that is available, another that is evaluated and functional, or that you have the results reproduced. Okay, so you can opt for the different batches. Besides, we have the reproducibility challenge, where a paper accepted on the previous conference is selected and is used in the reproducibility challenge in the students cluster competition. Then there is a subcommittee for the journal special issue that works with the student reports of the reproducibility challenge in order to make papers of their reports, no? Articles in the journal special issue. And in addition, the best artifact evaluated are selected and one is awarded with this Best Reproducibility Advancement Award. No? This was something new last year. So we have started this set of webinars. There has been one already done at the beginning of this week on E4S by Samir Shende, and it's already available through the website of this series of webinars. You have already the recording available, which can be very valuable for all of you. Today, we have a second webinar, and there will be a third one next Monday, which you can register using this QR code or simply accessing the website. You will have information. Okay? So today we are going to present Isabel Brunkan and Mike Sherman from Chameleon Cloud are going to present a webinar about the use of Chameleon. No? Chameleon is a very reconfigurable infrastructure that have different architecture and different type of devices like CPUs, GPUs, and FPGAs, different type of storage solutions, and different type of networking in such a way that you can reconfigure the actual infrastructure that you want to use, and also have other type of devices such as Raspberry Pis or Jetson Nanos that are adding then edge devices to this infrastructure. So the talk will cover these basics of the usage of Chameleon, including the use of Jupyter Notebooks, and also information on how you can get access to this infrastructure. So thank you very much. It's my pleasure then to introduce Isabel Brunkan that will be doing the presentation.
Yeah, thank you so much, Rosa, for that introduction. Let me just share my screen. Okay, and here we are. Okay, can you guys see it if I switch to the next slide? Yeah.
Yeah, perfect.
Perfect. Great. Okay, so thank you so much for having me here today. My name is Isabel Brunkan, and I'm the outreach lead at Chameleon, and I'm joined today by Michael Sherman, who is the University of Chicago site lead. I'll be giving the presentation, but Mike is here to answer any questions that can pop up, and we can also take some questions at the end, but feel free to drop them in chat as we go along. So today, as Rosa said, I'm going to be talking to you about how Chameleon can be used to help you prepare for the artifact description and artifact evaluation submissions for SC22, and essentially covering how you can use Chameleon for reproducibility. So I'll go over what Chameleon is for those of you who are unfamiliar with the testbed, the types of resources you can access, and how certain Chameleon integrations and features can be used to help you design your experiments for reproducibility. So with that being said, let's jump in. So what is Chameleon? First off, it's a bare metal cloud testbed designed for computer science research. So the testbed has a large capacity for storage, so you can run experiments with lots of data. We have many different networking options, and you'll see in the next few slides some examples of the different types of resources you can use on Chameleon. But what's unique is that you own the bare metal node. The node is completely isolated. You can power it on and off, reboot it. This is your node and not any other users, and so you're not competing for computing power. Second, the testbed is open and collaborative. So we've built a sharing platform, Trovy, which allows you to share your experiments as you would in Google Drive or Overleaf. You can share them with individuals or people within a project that you're working on, so creating a slightly larger sharing network, but still keeping it contained. Or you can share it publicly, which would allow anyone on Chameleon to access and rerun your experiment. Which is really beneficial for reproducibility. You can also, we've added a new feature called Daypass, which lets you create a QR code for your experiment. So you can include this on your paper or your poster. And so then when people in the future come and read it or read your paper, or see your poster at a conference, people can scan the QR code and run your experiment without having an active Chameleon allocation. And so this just kind of lets people who are not within the Chameleon network be able to reproduce your experiment. And finally, Chameleon is large scale and diverse. And so this is with respect to both the hardware and the users. We currently have almost 6,500 users from 160 institutions and 45 different countries with over 800 projects. We had 571 nodes across the two original sites, University of Chicago and TAC. And then in the past year, we've added 3 new sites at Northeastern University, at NCAR, which is the National Center for Atmospheric Research, and at EVL, which is the Electronic Visualization Lab at the University of Illinois Urbana-Champaign. And so the resources vary at each of these sites. So like NCAR has the ARM ThunderX2 nodes, while EVL has Haswell nodes. And so with a Chameleon account, you're able to access and experiment on any of these resources from the comfort of your own home. And we've been around for 7 years, and the NSF recently renewed our funding, so we still have 3 more years to grow. So with that being said, let's get into the details. So here we have a wide variety of hardware, storage, and networking capabilities. So these are just some of the examples of the different kinds of CPUs and GPUs and other options that we have. We've also, as Rosa mentioned at the beginning, added an edge testbed in the recent months. And so we have some Raspberry Pis and Jetson Nanos that you can experiment with for edge to cloud computing. And we're always adding more. And so when you have a Chameleon account and an allocation, you're able to use any of these resources and experiment on these resources. And you can explore all of the different kinds of hardware that we have and possible configurations at chameleoncloud.org/hardware. And the link is on the slide. So now that you have a general idea of the different types of resources that are available to you on Chameleon, let's talk about how you can use Chameleon to package your experiment in a reproducible manner for the ADAE submission. So when it comes to reproducibility on Chameleon, we recommend that you format the experiment in a way that you suggest the background about what the experiment is, what is the motivation behind it, how long it will take to run the experiment on Chameleon, and then you define a stopping condition. So what does success look like? And then you have a basic structure where you cover the background, you go over the basic methods and prerequisites. So if there are any required resources, what those are, any assumptions, what your experiment flow will look like. So do you reserve the resources? Then do you install machine learning libraries? And then do you run the experiment? Do you visualize the experiment in any way? So going over what kind of flow that would have. And then you document any packaged resources and other requirements there might be. And finally, then you have the experiment section where you have the steps to run the experiment so that the different users can rerun your experiment on Chameleon with the same resources that you did, and adding a little bit of documentation and explanation of each step. And so, as Rosa mentioned, the goal of reproducibility is to increase repeatability and be able to introduce controlled variation. And so some of the ways that Chameleon offers users the ability to package their experiments is explicitly defined in this way to encourage these goals. And so we have a lot of different options of how to package your experiments on Chameleon. But the first one, you can do it with orchestration, and so use a YAML heat template, and this is compatible with AWS CloudFormation. And one of the most common ways to do this is just to find a similar heat template and make small changes so that it works for your experiment. And so we do have heat templates on Chameleon. We have an entire webinar on orchestration on Chameleon, and so you're welcome to just go and follow along that webinar. And so making it a little bit easier for you to get started. The second option is just to do scripting. And so Python, Ansible, Bash, you can put the configuration and the execution steps in order, execute those scripts in order, and reserve your resources, create your instances, and run your experiments on Chameleon in this way. And then this can also be combined with the heat template. And then finally, the third option that we recommend for reproducibility on Chameleon is with Jupyter. And so we have an integration with Jupyter that lets you run code cells in Jupyter Notebook, and it reserves resources and configures resources on Chameleon itself. So you're coding in Jupyter, but you're using Chameleon resources. And so we recommend this for reproducibility just because it supports literate programming. So you can include both text and code. And in this way, you can add a little bit more explanation to what your experiment is. So for users who come back in, or even for yourself, if you come back to your experiment in future months, you'll know exactly what you're doing. And for users who have not seen what your experiment is or been able to read your have in-depth knowledge about your experiment, they can understand what your experiment does. And this interfaces directly with Chameleon itself, and you can use Python and Bash, and you can also combine it with the prior approaches. And so we have a lot of webinars available on our Chameleon Cloud YouTube channel. You can see an example here about how to use Jupyter on Chameleon. And so again, I would direct you to the YouTube channel. There are lots of resources on there for how to just follow along the steps to get started on Chameleon. And so I'm going to show you a little bit later on one of the experiments that we have packaged on Chameleon with Jupyter as an example of one way to package an experiment for reproducibility. But before we do that, there we go. I want to talk to you a little bit about our sharing platforms, because this is a resource that could be useful for you as you create your experiments, and allows you to collaborate as you run your experiments. And so Trovy is Chameleon's experiment portal, and it's very similar to Google Drive. If you package your experiments with a Jupyter Notebook integration, you'll save it to Trovy, and it's private to you unless you directly share it. And then there are multiple sharing options. You can share it with a specific member of your research group or a specific person, or you can share it within your research group, so like your Chameleon allocation, or alternatively, you can make it public. And in this case, your experiment would be accessible on Trovy to anyone with a Chameleon account. And so again, this is really just supportive of reproducibility by allowing any other users to experiment with your experiment. And so I'll also show you Trovy, and you can see how we have some resources available on Trovy already, or artifacts and experiments that you can rerun, some of which have been rerun hundreds of times. So again, this is just another really good resource to get your experiment out there, have people working with your research. And then finally, Daypass is one of our newest additions to Chameleon, and it's the external sharing method, where it is exactly what the name says, a Daypass to Chameleon. And so for people who do not have a Chameleon allocation, which all of you will as part of the SC22 ADAE, this allows people to rerun your experiment on Chameleon without having an account. And so you can, if somebody finds your experiment and you have enabled Daypass, they can go and click request Daypass. And then you'll be able to approve them, and they for a certain amount of time, and they will be able to rerun your experiment on Chameleon using the exact same resources that you did, and reproducing the experiment that you created. And so this is just a way to get your research out into the wider world for people who might not necessarily have a Chameleon account. And one of the most exciting things about Daypass is that you can create a QR code for your Daypass. And so you can include this QR code on a poster or in your paper. And so for example, the picture on the right is a part of a poster that was for the Supercomputing 21 conference. And so one of the students who created this poster enabled Daypass for his artifact and included the QR code on the poster. And so in this way, people who attended the conference or saw the poster, or even also if it was in the paper, read the paper, could just scan the QR code and then rerun the experiment. So it's not a static rerunning or static rereading of research anymore, but something much more interactive and more collaborative also, because you're sharing your research with people around the world. And so with that being said, heading on to the next example, we're going to take a look at how you can package your experiments in Jupyter Notebooks on Chameleon. And so if I go to the next here, this is our sharing portal Trovy. And so I've selected this AlexNet experiment, where it's a very simple notebook that illustrates how to create a reproducible experiment with machine learning. And so it replicates an implementation of the AlexNet model on the Stanford Docs data set. And so you can see at this point, it's been rerun 144 times. And so there's other experiments on Trovy that have also been rerun hundreds of times. And this is just another way to get your research out there. And so you would go to click launch on Chameleon. And then when you do this, it launches in a new tab on the Jupyter interface. And so this is one of the ways that we recommend packaging for reproducibility, by having a little bit of an explanation of what the experiment is on the top, background about the data set you're working with, potentially why it's important, and any requirements that you might have, such as in this case, you would need a Chameleon account. However, if this example was Daypass enabled, you wouldn't need a Chameleon account. Additionally, we recommend having the estimated time that it would take to rerun the experiment. And then, as I mentioned earlier, kind of the general steps of how this packaged experiment workflow is going to go. And so, as you can see, we've separated it into the experiment container setup portion, the machine learning experiment setup portion, and then the visualization setup portion. And so in this way, this is again packaged with reproducibility in mind, because we want to be able to allow people to introduce variation. And so they can introduce variation in the experiment container, perhaps change the GPU, change the CPU, change any of the resources that the experiment was traditionally run on, and run it on something new. Or in the machine learning side, this is all packaged in a separate Python script. And so people are able to adjust the machine learning side of the experiment if they were interested in introducing variation there. But this is kind of the general introduction of how we recommend setting up experiments on Jupyter for reproducibility. And then we also have some citations and other resources. And then finally, we get into the actual experiment where you create the experiment container. And so running this cell creates a reservation on Chameleon for whatever GPU or CPU or resource you select. And then you provision your resources. I'm not going to run this right now because it does take some time to set up, but I have the results pre-run so you can see the final result. And then configuring the instance. And so you see, depending on whether you chose to do a CPU or a GPU, we have a script set up here where you install, it's really just a batch file where you install the relevant files. And then we go into running the experiment. And so this is where the Python script comes in. And so you're able, the user, whether it's yourself or somebody who's rerunning this experiment in the future, is able to introduce variation in the experiment container setup part or in the machine learning experiment part, because these are separated into these kind of siloed areas. And so again, this is one of the reasons why we recommend setting up experiments in this way on Chameleon. And then finally, you perform the analysis and download and extract the results. And so once you do that, because this is Jupyter, you're able to open the analysis up and see the analysis just right there. And so these results will run on a Chameleon resource and then visualized right here on Jupyter. And so you can see kind of the results of the experiment. And again, we recommend having each of these experiments and machine learning portions set up in different scripts, because you're able to introduce variation, and tweaking part of one won't impact the other. And another potentially really great resource for you guys to use when you're creating the artifacts for SC22 is you can go in and go to the sharing portal and look at the different experiments that are available on Trovi, and see we have many different experiments, but you don't have to start from scratch. You can reuse some of these GPU setup scripts or a reservation script for your experiments. So that's just one less step of work that you have to do, because somebody has already created these. And so you can just adjust them for your purposes. Yes, and then the next thing I wanted to show you guys is our resources that are available on the YouTube channel. So here's our Chameleon Cloud YouTube channel. As I mentioned before, we have introductions to Chameleon. We have orchestration with heat templates or with Jupyter Notebooks, and then additional resources available, such as information about Chi@Edge, our edge computing resource, in case anyone is interested in that. And so this is just a really great resource to be able to get an additional introduction to Chameleon, be able to follow along the steps, and then again, as I mentioned, perhaps repurpose some of the scripts that are used in the webinars or resources on there. Additionally, you can check out our the Chameleon blog, which has we have a whole section on tips and tricks blogs, and so one of the potentially most helpful tips and tricks blogs for you as you begin packaging experiments for reproducibility is this blog, which covers different introductions to Chameleon, orchestration, and then also some networking resources, edge computing, and then reproducible experiments you can run yourself. And so we have lots of mini experiments that we have packaged. And so these are like 4 to 7 minute videos that students have packaged or who have created about packaged experiments. And so you can follow along with these videos as a way to do a quick start to Chameleon. Okay. And then so going back to the presentation, this is again, kind of, this list highlights some of the resources that I mentioned before. We have a collection of experiments that were reproduced over the summer of 2020. And so I think there are about 5 different experiments that were reproduced. And the 5-minute reproducible experiment videos that were a part of the blog post that I just showed you are in relation to this collection of experiments that were reproduced over the summer. And so again, these are just very simple experiments, but for you guys, as you begin packaging experiments for reproducibility for SC22, you can reuse some of these scripts that were used in these experiments. Additionally, we have how to use Chameleon on YouTube, and a blog post specifically about using Chameleon for artifact evaluation based on how Chameleon was used for artifact evaluation in the last supercomputing conference. And then we also have more resources available on ChameleonCloud.org. There's documentation, there's an FAQ, frequently asked questions, and then we have our blog. And you can use our blog also as inspiration. We have monthly we feature users who are doing experiments on Chameleon. And so you can see some examples of what other users are doing on Chameleon and how they are setting up experiments. Additionally, I would just recommend poking around Trovy because some researchers have made their experiments public. And so you're able to reproduce those experiments while also looking at some of the resources that the Chameleon team has made and the smaller experiments that we've packaged. And finally, we are here to help. If you have any questions, any recommendations, running into any troubles, we are here. You can email us at help@chameleoncloud.org. And we're on social media, the YouTube channel you already saw, then there's Twitter, LinkedIn, and Facebook at Chameleon Cloud. Thank you very much.
Thank you, Isabel. It's been great. So we can now take questions. I don't know if any of you can just raise a hand or open mic, whatever you prefer. Well, people decide to ask. I think that the QR code that Daypass is very cool. And then I understand that in this case, if the Daypass is enabled, whoever runs the experiment, it's using the author's allocation, no? I don't know if I'm clear. With the Daypass, what you get access is you will be using resources of the author of the experiment, isn't it?
Mike, do you want to take that one?
I believe that is correct. We had looked into creating like a second allocation for Daypass authors, but that's not implemented yet.
Okay. Okay, and then if I was an author, how I get access to Chameleon?
So just generally as an author, if you weren't part of this SC22 reproducibility, you would just go to the Chameleon website and sign up for an account. And if you're a faculty at a university, you can apply to basically get your own allocation. Otherwise, if you're a grad student, you would ask your PI to do that.
Okay. And sorry, go ahead. There was an interruption.
Yeah, but the last part is for this SC22 reproducibility, we'll be creating an allocation and inviting people.
For the artifact evaluators, you mean?
Yep. Yep.
Okay, great. Thank you. Anybody else wants to ask anything? Sorry. Well, if not, I have a few more.
I do have one, Rosa.
Great, go ahead.
Can you talk a little bit about the limits in terms of size for those allocations? So if the authors have something that is distributed, how many nodes can they access? If they have something that is parallel, how many cores do they have access to? Memory as well, things like that.
Okay, so our allocations are generally not very restrictive. It's really there to prevent abuse. Rather than strict memory and core limits, you can really make reservations for whatever is available at that moment. We've had people reserve 50 machines at a time. Really, we just ask people not to, reserve everything that they don't need. But there's no meaningful limits to prevent, larger scale experiments, especially if it's for a shorter duration. What you would find out is, if you reserve 50 machines, you would run out of the sort of allocation credits well before the sort of 6-month default duration. And then you would apply for a refill, and we would ask you why you used so many machines.
Okay, excellent. A follow-up question would be, outside of AD, is it possible to use it for tutorials? The Daypass, I'm sorry.
Sorry, could you repeat the first part of the question?
Yeah, so other than ADAE, other than reproducibility, can you use the Daypass for tutorials?
Oh yeah, no, you can use the Daypass for any purpose. Basically, when you enable that Daypass as the author, you're basically saying, whoever it is can use some Chameleon resources and launch this artifact for whatever purpose that is. The only thing to note is that that person is kind of coming in under your scope of access, and so you do want to just sort of like not do this arbitrarily. But no, you can absolutely use it for tutorials, whatever else you want to.
And just one thing that might be useful, Jose, we also have, in regards to your first question with the resources, the host calendar, which I'll just share my screen really quickly, which allows you to see what resources are available. And so you can use this to also kind of plan like what your experiments are. And so you could go and select if you want to run it on a specific resource. You can go and see like when these resources would be available and kind of optimize your experimenting, which isn't in relation to your how much resources do we get, but this is just another really cool trick that you can use to plan your experimenting.
Bilal, go ahead.
Thank you, Isabel and Mike, for the follow-up, for the presentation and follow-up question. Really appreciate it. So so as you know, at SC we have also like not only like US authors, but also we have people who are located outside of the US. So can they use for SC temporarily Chameleon to build the repo with Chameleon for the artifact?
So generally, the way we handle non-US authors is it's fine so long as they're on a project that has sort of a US person as the lead. Really, it's the allocation that is tied to the US requirement. but other people can be added as members of that.
Okay, thanks for the clarification.
Any other question? I have one. When you show the AlexNet example, I saw that the DOI was referenced at the below, no? So these DOIs are automatically obtained, or how we add it to the experiment?
Yeah, so at the time we, this was before Trovi, when Trovi was beginning to be implemented. And so at that time you uploaded, you could upload the experiment to Zenodo. And so it was Zenodo that would give you the DOI. Mike, I'm not sure, is the Zenodo integration still available as an option? We've kind of replaced the DOI with the QR code as a way to like publicly share the experiments.
It should still be available. I'll check on that.
Okay, perfect. Yeah, I can follow up on that too. But yeah, so DOI and then Daypass with the QR code or a link. And so it's just multiple ways of publicly sharing an experiment.
Oh, the QR code is very nice for the posters, but for the papers, I would recommend a DOI. I think it can be a better option. And in general, if you need to keep the data on the package, I think it's better to have a DOI. So
yeah, I just confirmed with the DOI is still there and it is separate from the QR code.
Okay, great. So you can have both. I have no more questions at this point. Veronica, sorry, go ahead.
No problem. Thanks, Rosa. Just one quick question, like for some authors that may have like big data sets, are you connected? Is it easy to transfer data into Chameleon? Like if you have terabytes of data that you want to reproduce, or do you recommend only doing like a smaller experiments?
So terabytes of data might be a bit time consuming, but we do have a large object store and we're attached to the various scientific networks at 100G. And so it might take a while to upload, but you could import large data sets.
Okay. And do you have like a Globus endpoint that authors could use to transfer, or?
We don't currently have a Globus endpoint. But that is something that we should look into. Most of our reproducibility requests have been more in the sense of executing systems research rather than sort of processing large amounts of data.
Okay, that makes sense. Thank you.
Okay, so I don't know if there is not any outstanding question. I would like to thank Isabel and Michael for the presentation and answering the questions. I don't know if Bilal wants to add anything else as chair of the.
I would like to again to thank you, Rosa, for coordinating this webinar, and again thanks all the committee member, and of course Isabel and Mike for taking. I know like some of you is early in the morning and some it's late, so thank you. So. For the attendees, there will be the recording available. And if you have any question, our email will be, the committee email is shared. So please don't hesitate, don't be shy and contact us. And also Isabel and Mike, they shared like also, they have the nice Twitter and also mailing. So please don't be shy to contact them.
Okay, perfect. Jose, you can stop. Yeah, thank you, Isabel. Very nice meeting you finally. Jose,